Today we start super important topic. Many even senior software engineers couldn't apply and practice all aspects of this knowledge. Because to understand this topic from all sides you need to practice a lot. As you get more experience, all information which I'm going to share with you will start make sense. I spent a lot of time to select the right wording to make complex things easier. And today I will try to explain you object-oriented programming. So today let's start from OOP basics. In this lesson we'll learn theory and I will explain you in simple words what object-oriented programming is. Today we are going to discuss what object-oriented programming means, and it is always better to understand first why we need OOP and how it can help us in creating software. We'll briefly discuss functional programming approach so you would be able to understand the difference and better understand OOP approach. And taking into account that this is lesson about OOP basics, we'll talk about key object-oriented programming principles. So, let's start. Let's come up with definition of OOP first. There are multiple definitions of what is OOP. I am going to share with you different ones and my own. Wikipedia tells us that OOP is programming paradigm based on the concept of object. Other definition of OOP is the next one. OOP is a computer programming model that organizes software design around the objects rather than functions. This definition clearly describes the difference between OOP and functional programming. We'll talk about functional programming a little bit later. My own definition sounds like this. Object-oriented programming is a software design approach in which concept of object occupies the first place. In each definition we see that the concept of object is mentioned. Okay, then let's find the answer on the next question. What is an object? In object-oriented programming, everything is an object. Array is the object. Connection to database is the object. Unexpected situation during the program execution is the object. But this definition is very vast. We need more specifics. And let me simplify the definition of the object. Imagine a car. A car has doors, headlights, body, wheels, trunk, engine inside it, steering wheel, color, and lots more. What we have just described is called data structure. We describe something abstract with key properties which allow us to distinguish car from plane. Right now we have nothing more than list of properties which brings us to specific data organization that enables efficient access and modification. We can change wheels if we want, or we can change color of the car, but this will be still a pure data structure in our program. What does this car need to become an object? This car needs to have behavior which will allow to manipulate with its own data, the properties we have listed. We call this behavior methods. Imagine that car has such behavior as turn on the headlight, or start engine, or turn right, or turn left, and so on. In case our car has such behavior, we can call it the object. Now let me share with you my own definition of object. Object, first of all, is a virtual entity with specific list of properties which can distinguish it from other objects and behavior which allow to manipulate with these properties. In other words, data plus behavior equals to object. Does it make sense? Object is always an instance of some specific class. Things become more interesting, huh? Now we need to understand what a class is. I will try to explain what class is in few words, because we are going to have separate lesson dedicated to classes. But you need to understand the concept of the class now to understand what object is. Treat to a class as to template for an object. Imagine you are a car manufacturer, and you need to create millions of cars. You know that each car will have color, wheels, body, headlights, engine, and lots more. We also know that cars should be able to drive, start and stop engine, accelerate, brake, and so on. We have just described a class for a car with properties and behavior, but each car might have different color, different body, petrol engine or diesel engine or electric one. Besides that, each car can drive radically differently. I believe now you understand that object always an instance of some class. If you understand this, we are ready to move on. Probably you are interested what other approaches for software development exist. One of the most popular programming paradigms is functional programming. If in object-oriented programming our main concept is object, in functional programming our main concept is function. In other words, functional programming is not bothering about grouping data together with related behavior and about describing of control flow. We have specific task and we have specific function that can deal with this task. Functional programming expresses the logic of a computation. Which approach is better? This is wrong question, because it is not complete enough. The right question is which approach is better for some specific task. Because functional programming approach works the best where you don't care about order of functions execution. For simple data manipulations, functional programming solution in some degree is easier and faster to implement. Sometimes it is even easier to support. But for complex enterprise solutions, functional programming approach can turn your project maintenance into a nightmare. Object-oriented approach allows you to organize your code and program execution in structured way. During the course we'll discuss with you different clean code techniques which relies on basic OOP principles. So now I believe you understand the difference between OOP and functional programming. Let's name exact reasons why and when we need to follow OOP design. Nowadays you can't implement mobile application or web application if you don't understand OOP approach. OOP in most cases is the most natural and pragmatic approach. I'm not trying to say that OOP is the one true way. I just want to highlight the list of advantages which in most cases helps to solve even complex software development tasks. Modularity. In case something goes wrong in your program, you know where to look. Are there problems with calculation of personal discount for user? We need to take a look at user object. If you would follow key OOP principles, your code will be structured. OOP allows you to have low coupling in your code and high cohesion, which makes maintenance of your code much easier. Scalability. Because of modularity and if you follow OOP design principles, you can scale your software easily and in predictable manner. If you don't follow OOP approach, adding of new piece of functionality in your program may cause significant changes in all existing code, which in turn increase risk of new defects associated with those changes. Lower cost of development. OOP design allows you to reuse code. When you reuse code, you decrease number of places where potential defects can appear. Also, you spend less time to reuse already existing method than to write new method from scratch. Security and reliability. Basic OOP principles allow you to hide details of implementation from user of your objects. OOP design allows you to build robust design with independent modules. That in turn makes your software more secure and reliable. Definitely, when you become senior developer, you would find disadvantages in OOP. But when candidate starts arguing with me during the interview and hating OOP approach, usually I ask him what is better for some imaginary business case. And these people always lose this fight. Because you need to understand that programming is always just a question of trade-offs between maintainability, scalability, speed of development, code quality, and reliability. And now, when you understand on a high level what is object-oriented programming and why we need to learn it, let's review basic OOP principles. They are inheritance, encapsulation, polymorphism, abstraction. Let's go one by one. Inheritance. To understand inheritance, let's consider the next example. Do you remember we discussed class of the car earlier in this lesson? And now imagine that you need to create not sedan, but sport car, or family car with extra seats. Would you describe class for sport car from scratch? You don't need to do this, because sport car also going to have 4 wheels, also going to have engine, but something would be different. Most likely you are going to have only 2 seats in the car, and additional attributes of the sport car like spoiler, probably clutch pedal for sport manual transmission and something else. I believe you got my point. Inheritance allows you to create new class based on another one. New class can extend existing one and share properties and behavior. New class is called child class and basic class is called parent class. Inheritance allows you to reuse code and to create new classes without reinventing the wheel. Encapsulation. The key principle tells us to keep data and code that can manipulate this data together. It is also about keeping data and the code safe from external interference. To understand it better, let me demonstrate encapsulation in real life. You have a car. Car is a separate object, and there is a gas pedal in it. Gas pedal is external interface which sets the way how we will interact with our car. When we push down gas pedal, a lot of things happen. Throttle is opening to let some air in, meanwhile fuel is fed through intake manifold, sensor regulate when throttle should be closed, and so on. And everything is done to accelerate your car. Do you see how many details are encapsulated from you inside the car? But you don't care. You don't want to control all these actions. You just want to push gas pedal to accelerate your car. and you don't have access and control how much fuel to feed in different cases. You let your car handle such kind of questions. Do you understand better now what is encapsulation? In programming, access modifiers exist to facilitate the encapsulation of components. For example, in Java you have next access modifiers. Private, the strictest one. You have access to fields and methods only within the specific class. You can't access private elements outside of this class. Default, access level within the same package. Elements with default access modifier can be accessed outside of the package. Protected, access level within the package and outside of the package in the child classes. Access outside of the package and outside of a child classes is not possible. Public, access level from everywhere. You can access elements with public modifier from within the class, outside of the class, within the package, and outside of the package. To keep focus on the basic OOP principles in this lesson, we'll discuss only theory. In the next lessons, we'll make a deep dive into practice part, including access modifiers. I believe now it is clear what does encapsulation principle mean. The next principle is polymorphism. Let me explain polymorphism in simple words and again with car example. Imagine you have two different cars, one with electric engine, another with petrol engine. Both are going to have button Start Engine. In both cases behavior will be similar. Engine will be started and you will be able to drive. But the way how engine will be started is completely different. In car with petrol engine, car's system will feed fuel to the engine to start it. In car with electric engine, a huge blast of power will drive your car. Or like it's shown on the slide, you have steering wheel, and each car has. But the way how steering system work is different in each car in this example. You can have single interface but multiple implementations. Do you feel what polymorphism is all about? The same word can mean different things in different contexts. What we have just discussed called method overriding. You override behavior. In the separate lesson I am going to show you how polymorphism works in Java. For now, I need you to understand the concept of OOP and basic principles. And the last but not the least principle is abstraction. In some literature this principle even not mentioned as a basic OOP principle. But I believe we can consider this principle as important as other ones we discussed. Let me explain you what abstraction is. If I would ask you what is the difference between a car and a plane, what would you say? You would try to list some key features of a car and a plane. You are trying to come up with abstraction which should be enough to differentiate car and plane. Create abstraction which works the best for your business needs. It is not easy thing to do. But if you create good abstraction for a specific case, it would allow you to not duplicate code, to support good scalability of your units and lots more. This principle is a very important one, and it requires time to use it in the right manner. Let's take a look now what we have learned today. Today we learned what is OOP and what is the difference between object-oriented and functional programming. We discussed advantages of OOP and why we need to learn it. And what is also very important, we learned basic OOP principles. That's all what I wanted to share with you in this lesson. This is our start of learning of object-oriented programming. I would be glad to recommend you literature to read as your homework, but I wouldn't recommend you read anything so far. My opinion, the topic of object-oriented programming in majority books described chaotically. By saying this, I mean in books a lot of terms, code structures, new keywords which we are going to learn are mixed in the same chapters. I spend a lot of time thinking on the structure of lessons and how to explain OOP to my students. And my experience of teaching proves that the sequence of lessons which I suggest brings a clear vision of OOP in the shortest possible time. So now, make sure you understand content of this lesson before we move further.